Actually, the story about these open doors reminded me of walking into a cafe in London on a freezing cold day, sort of minus 2 degrees, and all the doors wide open. And I said to the lady behind the counter, whether there was any chance to close those doors. You know, I look at them and it just hurts me. And I'm of course thinking energy. She said, do you want me to turn the heating up? So that backfired. Anyway, that's open doors. I'm here to talk to you about smartphones and how we try to use them to make smarter meters. And this is very much work that I'm presenting on behalf of Russell. Really, he's the brains behind it all. I'm just talking about it. But let me show you where it all began. This is, well, you know what this is. They wanted to find out where all their energy is being used. And just looking at the picture, you probably get the first clue where a lot is being used. But what happened to them was they got the works of installation, of measurement, of data collection for vast amounts of money, collecting bags and bags of data. I mean, it sat there. Nobody used it. And a lot of the data wasn't actually very useful either, because not much was happening on those meters. You know, these buildings have loads and loads of meters. So something needed to be done slightly differently to make that process, A, cheaper, and B, maybe work a bit more effectively. Now, Katie impressed on me, I have to show you an example of the retail sector here. So this is my best example of the retail sector. It doesn't look like retail, but believe me, it is. This is Blenheim Palace. They do loads of things. They've got their own bottling plant, they've got visitor attractions, they've got their shops, cafes. There's an awful lot going on, which also means there's an awful lot you need to do to find out where they're using their energy. Again, a lot of meters, a lot of different uses. And in this sort of context, you realize it's not enough just to know where the energy is being used. You want to know a bit more. You want to know why is it being used and what causes that energy use. And for them, almost everything is measured against visitor numbers. But is that a good index to then compare your energy consumption against? You know, in September, they spent £16,000 on electricity in September, 1 month alone, which they could then say, oh, that's a good sign, because that means visitor numbers are up. You know, that's all as it should be. But you actually want to understand, what are the relationships? So we need to dig a little bit deeper. Now, this is the conventional way to do it. Smart meters, we've heard about them. Every meter point gets one of those. It is somewhat costly to install them because somebody has to go there, actually work with wires. And then the data it doesn't have to be difficult to access, but very often it is very hard to get hold of this data. And ashamedly for me as a slight energy nerd to say this, but I think energy-only data is also a little bit boring, because it's only energy. So here is what we're proposing to do. Here's a smartphone, which on its own is a bit boring, but if you combine it with a Russell Avery, it becomes very, very interesting indeed. So what we have here is actually a fantastic device which, we're picking them up for sort of £50, and it comes with a camera. So we've got a light sensor, we've got, well, in essence, a camera, we've got motion sensors, we've got GPS, we've got Wi-Fi, so we've got communication, we've got location information, we've got the mobile phone function, so it can talk to networks. Of course, we can program these things. We've got a screen that we can enter information with, so it's a very versatile device. But the really exciting thing about it, and what Russ very cunningly identified, is that microphone jack. That's the really attractive thing for us, because what that is, if you think about it carefully, it's a voltmeter. You can measure voltages on the microphone jack, and better still, because it's a microphone, it records a trail of voltages, so really it's more like an oscilloscope. So we can sample at 44 kilohertz information. And what we'll do with that, in fact I can demonstrate, because I've got a smartphone here, all that needs doing is you take a current clamp, solder a jack to it, and plug it in, and there is your somewhat smarter meter with all sorts of possibilities attached to it. And with this, as Malcolm explained, resolution is very important. Now this comes nowhere close to what Malcolm can measure in terms of temporal resolution, and the accuracy would also not be the same. But we can sample 1 second intervals. The data can be instantly accessible on a website, where you can see what's happening at that time. And what you can do, because it's somewhat portable and flexible, you can put it on different locations and just find out what's going on. And once you've found the most interesting areas, then you can start analyzing and dig a little bit deeper. So you can start with your 1 meter that takes the electricity consumption. You can then, with that Wi-Fi, talk to other devices, which could be attached to appliances. So you can dig that level deeper to find out what's going on. You can then have a bit of background information, so light levels, temperatures. Obviously, those matter. If you don't correct for temperatures, your readings are a little bit out of context. You could include weather data. Again, very important for heating in particular. And this is what I want to put to you. There must be other things that are interesting. I mean, I mentioned, for Blenheim Palace, they're very interested to, correlate the energy consumption with visitor numbers. But there must be a lot of other things that might be interesting to you to find out, how does this relate to energy consumption? The more detail we can find there, the more you don't just get an energy number, you actually get causalities, and then you can act on those and make a real difference. So I leave that one to you. I'd love to hear from you, what those other things could be, should be, because this device is at the moment so mind-bogglingly versatile that, anything could be measured, and we'd love to try that out with you. So please approach us with ideas for what sort of things one should measure to get more information and more intelligence into the data that we're collecting. And with that, we can then answer the why question. Thank you very much. Any questions?